Here we go. So now let's try to summarize everything what it covers so far, okay? So actually we did everything here, okay? So here we go. So first of all, as I told you, to talk about the area under the curve, and we need to use the rectangles to approximate the value, right? But like it's not approximation anymore because we gonna apply the limit value, okay? As you can see here, okay? Limit value, okay? So first of all, let's come back to the like area rectangle, okay? So as we talked about it, you need the base of each rectangle. There we go. Can you find this guy? Delta x. B is right end point or upper limit, and A is left hand point or lower limit, okay? Delta x is the base of each rectangle. It can be calculated by b minus a over n. N is the number of rectangle, okay? And then we need height of each rectangle, okay? In this statement, I notate by x1 star, x2 star, dot, dot, xn star, right? But for this course, we can use only 3 different points, okay? Right hand point, or left hand point, or midpoint, okay? But like for like this definition, if you can understand, or if you can construct the area rectangle with the right end point, that'll be fine. That's enough, okay? So anyway, look at that. What is that? The definite integral, the notation meaning of this one is what? Area under the curve f of x between a to b is equal to limit of Riemann sum. That's it, okay? As you can see in here, like in the like sigma notation, delta x is the base, and f of xi star is the height, right? And that's it, okay? This is what we talked about before, okay? So now, like, you know, the couple of like notations, like, you know, we can say f of x is integrand and lower limit and upper limit, okay? That's it. Now let's talk about a little bit more about the integral, okay? By the way, at the beginning of this class, did I say the definite integral means the area under the curve? To be honest, it was wrong, okay? So actually like it is net area, okay? Let me try to explain what is different between area and net area, okay? Basically, we assume your function f was positive. Then it is exactly area. Integral means the area, okay? But think about the definition, okay? So let me give it to them, right? So first of all, the case your function is positive, like that, from a to b. Then if you just want to talk about this area, your area is exactly equal to the definite integral a to b f of x dx. This is true, okay? But what about the other case? If your function is negative function like that, let's say it is gx, okay? From a to b. If you just want to find the area of this guy is equal to negative value of integral. Well, first of all, area cannot be negative, okay? But since this integral value will be negative, so negative times negative is positive now, okay? So you're gonna have like positive area, okay? And can you understand this one? Well, if you think about the definition of integral, it is easy. Think about it. Like to evaluate the definition, evaluate the integral, we used the area rectangle, okay? And the base was just like size of each rectangles, right? Subinterval, right? But the height was the function value. Do you remember? Okay? So like for this one, it is fine. Your function value is positive number, so like it is exactly positive area, right? But for this kind of negative function, the function value will be negative, then your area of each rectangle will be noted by negative. Whenever you add up everything, you will have like total negative value. Okay, that's why, like, but fortunately, like this case, like it is not mixed up, but like just like simply purely negative function. That's why we can say the area will be just like an opposite of your integral value. Okay, but if it is mixed up, negative part and positive part, and you have to treat a little bit different way. Okay, so like that is the meaning of net area. Okay, let me give you the example. Okay, so now let's talk about this problem. Okay, so the function graph is given, and I gave you the area which is enclosed by the curve and x-axis, okay? This one is 10, 20, 15, and 40, okay? So now, like I believe you understand about, you understood about the meaning of net area, right? So like, which means the relation between the enclosed area and the integral, definite integral value, okay? So here we go. Let's start from the problem A, okay? Integral 0 to a f of x dx, right? 0 to a. They would like talk about the area under the curve like from here, right? But your function is negative function, right? Then what about your, like what about the integral value is? Definitely it must be negative area, right? So this must be equal to negative 10. Does it make sense? This is the meaning of net area, okay? What about second one? A to B. A to B. Oh, like between A to B is positive function, so which means your area will be exactly the same with the definite integral, okay? So the answer for this one is simply 20, right? Then what about C? This is the case, the mixed up, right? 0 to C. 0 to C, you have the negative function part, positive function part, and negative function part, right? So which means negative function part must be negative, and positive function part must be positive, and negative must be negative, right? So this guy is equal to negative 10, positive part, and negative part. So this must be equal to negative 5. So what I want to say is the integral is not simply area, but it is net area, okay? So here we go. So what about D? 0 to D, like from the beginning to the end. We already understand about this one, right? This concept, right? Net area, okay? Negative part must be negative, positive part, and negative part, and positive, which is equal to 35. Net area, okay? And what about E? Well, we will talk about this one later. Basically, like, so far we talked about your definite integral must be left side to the right side, right? But this one, it is backward, right? So basically, we will talk about this one later in the property. The backward means just like, negative, okay? So like this integral can be written by minus integral a to c, which is like opposite direction with f of x dx, right? So which is negative. What is integral a to c? A to c is 20 positive and 15 negative, right? 20 minus 15, that is negative 5. Okay? Oh, it's overlap, right? Give me 1 second. So 20 positive and 15 negative, right? So let me write here, okay? 20 positive, negative, 20 positive, and 15 negative. So the answer is negative 5. Okay? So what about the other one? Look at that. Well, if you understand about definition of the integral, it is really easy. C to C, which means there's no base. Your base is equal to 0 and times height. Like since you multiply 0, no matter what equal to 0. That's it.